everyone, welcome back to SyntaxGrid, your go-to channel for all things machine learning and data science. Today, we're diving into one of the most powerful and widely used machine learning algorithms, logistic regression. Let's get started. In this video, we are going through Introduction, why not use linear regression for classification, sigmoid function and decision boundary, cost function and optimization, multi-class logistic regression, Softmax, model performance evaluation, handling imbalanced data, pros and cons, real-world applications and conclusion. 1. Introduction. Logistic regression is a classification algorithm used to predict categorical outcomes. Example, yes or no, spam or not spam. Unlike linear regression, it predicts probabilities and maps them to a binary class using the sigmoid function. Example, predicting whether a customer will buy a product, yes or no, based on browsing history and past purchases. 2. Why not we use linear regression for classification? Linear regression provides continuous values, which are not ideal for classification. It doesn't restrict output between 0 and 1. Sensitive to outliers, leading to inaccurate classification. Example, if we use linear regression to classify whether a tumor is malignant, 1, or benign, 0, it may predict a value like 1.3, which is not meaningful. 3. Sigmoid function and decision boundary. The sigmoid function converts any real number into a probability between 0 and 1. The decision boundary helps classify data. If output greater than 0.5, class 1. If output less than or equal to 0.5, class 0. Example, in spam detection, if an email's spam score is 0.7, it is classified as spam, 1. If 0.3, it's classified as not spam, 0. 4. Cost function and optimization. Why MSE fails? Leads to non-convex optimization, making it hard to minimize. Ensures well-optimized probability predictions. Gradient descent is used to minimize the cost function and find the best model parameters. Example, in medical diagnosis, the model predicts the probability of diabetes. Log loss ensures confident wrong predictions are penalized more than less confident wrong predictions. 5. Multi-class logistic regression, Softmax. Logistic regression is primarily for binary classification. Softmax regression extends it to multi-class problems by assigning probabilities to multiple classes. Example, predicting weather conditions as sunny, cloudy, or rainy, using temperature, humidity, and wind speed. 6. Handling imbalanced data. Resampling techniques. Oversampling, SMOTE. Synthetic minority oversampling technique. Undersampling. Randomly removing majority class instances. Adjusting class weights, penalizing incorrect predictions for the minority class. Threshold tuning, changing the decision boundary based on business needs. Example, in credit card fraud detection, fraudulent transactions are rare, so SMOTE can be used to balance the dataset. 7. Model performance evaluation, accuracy, measures how many predictions are correct. Precision and recall, important for imbalanced datasets. F1 score, harmonic mean of precision and recall. ROC curve and AUC score, evaluates model performance across different classification thresholds. 8. Pros and cons. Advantages. Simple and easy to interpret, works well for small datasets, provides probability scores. Disadvantages. Assumes linear decision boundaries, struggles with complex relationships. Not ideal for large datasets with many features. 9. Real-world applications. Spam detection. Logistic regression helps filter out spam emails by analyzing the content and classifying them as spam or not based on predefined patterns. Credit card fraud detection. The model predicts fraudulent transactions by analyzing spending behavior and detecting anomalies in transaction patterns. Medical diagnosis, disease prediction. Logistic regression assists in predicting the likelihood of diseases based on patient data such as symptoms, medical history, and test results. Customer churn prediction. Businesses use logistic regression to identify customers who are likely to stop using a service based on behavioral data, enabling targeted retention strategies. Conclusion: logistic regression is a foundational classification algorithm used in many real-world applications. In the next video, we'll implement logistic regression in Python from scratch. Check out other machine learning topics on the channel and subscribe for future videos.